Okay, folks, this is section 8.2, part 2. I'm going to do a couple examples for you of solving systems using your TI Inspire calculator. We're going to use the matrix menu for this, and that's one we haven't seen before. Here's a system I'll solve for you. It's got three equations, three linear equations in x, y, and z. This is an augmented matrix that represents this system. So this is the matrix I'll be working with in the calculator. So first thing I'm going to do is I'm going to open a new document, and I'm going to go ahead and insert a calculator page. Now what I'd like to do is show you the matrix menu. So I'm going to go to menu, option 7 is matrix, and then I have a whole bunch of different options here. First one we'll look at is create. So I'd like to create a matrix. I need one with 3 rows and 4 columns to replicate this guy here. So I'm going to go ahead and increase that to 3 rows and 4 columns. And then I'm going to go ahead, the calculator is going to give me the space to do that. So I'm going to enter all my values. And -18. Now, this is something that is good practice for you as a student. Go back and double check. Go back and look at each value and make sure that you type those in correctly. I can't tell you how many students have been convinced they've tried it 3 times and they know they're right and WebAssign is wrong, only to find that they did something like made this a -2 instead of a regular 2. So double check your values for your coefficients and constants. Well, I'd like to work with this matrix in a couple different ways. So instead of having to retype it, I think I'd like to store it in my calculator memory. So I'm going to go ahead and store it to the value A. So that matrix is now stored to the value A in my calculator. The next thing I'd like to do is show you row echelon form. Row echelon form is going to give me 1s down the diagonal, 0s in the lower left-hand corner. That can be used to, once I'm in row echelon form, I'm going to be able to know what Z is and then work backwards to find Y and X. So let's see how to do that. Matrix, oh look at this, row echelon form, there it is right there. So I want row echelon form of matrix A. Bingo, there it is. Z equals -2, and then I can work backwards through these other 2 equations in the system to find out what Y and X are. Something that's even more convenient is reduced row echelon form. Let's take a look at that guy. So it's option number 5 within the matrix submenu. Oh, look at that. It's just RREF. If I want reduced row echelon form of matrix A, now this is where you should prepare to be amazed. So you may want to make sure you're sitting down right here. Grip it and rip it, and we get the solution to our system. X equals 1, Y equals 3, Z equals -2. Thank you. Good night. Wasn't that is infinitely easier than trying to do one of these matrix problems by hand. Okay. So I'm going to do one more example for you, and through the magic of modern technology, I can slide my calculator to the left and reveal another system. We're going to go ahead and use the calculator to do that one right now. All right, folks, so I'm going to go ahead and solve this system right now using my calculator. And the last time I went through the matrix menu to show you all those options, this time I'm going to show you a couple shortcuts. So I'm going to escape out of there, and I'm going to show you in the symbols menu, I have this matrix symbol right here. So through that symbol, and I'm going to go back and show that to you one more time. Symbol template, matrix. I can now pick a matrix of R by C, rows by columns. I need 3 rows and 4 columns. So there we go. I'm now going to enter the constants and coefficients for my matrix. As I mentioned before, you need to double check and make sure each of those values was entered correctly. And it looks like I'm good to go. One thing here that's worth noting, notice the third equation in this system is x minus y equals 2. In my matrix, that looks like 1, -1, 0. Why is 0, 0 here? Well, this column represents the variable z, and there is no z in this third equation. So that right there is an opportunity for students to make mistakes. Okay, so now that I have my matrix entered, let's store this one to a different variable name. How about we let's pick something unique. How about VAS? We're going to store this one to the name VAS. That seems like as good a name as any. So we went ahead and stored that matrix to VAS. And if you recall, I'm going to scroll back up here a little bit. I called the command ref, which stands for row echelon form of A. Well, I can find that through the menu, or I can just type it. If you're faster at typing that on your calculator than finding it in the menu, you can do that. So I want now the ref of VAS. Boom, I get this. Now, this is a problem. And I want you to take a look at this before I reveal the problem, and I want you to pause the video and see if you can figure out the problem before I tell you what it is. All right, I hope you've taken a look at that now, and you see that the problem lies right here. We have 0 equals 1. Remember, this represents 0 x's plus 0 y's plus 0 z's, so that's a total of 0 equals 1. I don't know if you have heard this before, but 0 does not equal 1. So this system is inconsistent and there is no solution. Unfortunately, there was no solution for the matrix VAS. Just to show you the reduced row echelon form and what that looks like with an inconsistent system, I'll go ahead and show you that now. We get this. We get something very similar. The top two rows look different, but we still get 0 equals 1. And that's false. This system is inconsistent. No solution. Thank you. Good night.